Array-oriented programming is a reference to vectorized operations that we can run at high speed on potentially very large arrays of values. What we're creating here is a one-dimensional array that runs from -5 up to 4 in steps of 1. So it'll create 10 values. And then we're using NP mesh grid. Then we're putting that array inside mesh grid twice. And we're unpacking it into an XS array and a YS array. So these are X values and Y values. And what mesh grid will do is it'll create a rectangular array of X values, and it'll create an exactly corresponding rectangular array of Y values. And we're going to use these to create a plot down here on a Cartesian plane. So let me run this plot, and you'll see that we have 100 values now. This is the x-axis, and this is the y-axis. That's what mesh grid does. What we would like to do, however, is have more points here. Instead of taking steps of 1, we say take steps of 0.5 instead. That should create 200 points, shouldn't it? So let's run this again and see how our grid changes. It's a much more densely packed grid. So how would we make 1,000 points here? It would be a 0.01, wouldn't it? Because that would be 10 times 100. So 0.01. And let's run this. And then let's run this. We have so many points now that it's hard to get to the bottom of them. Should be 1,000 points. And they're packed so densely in here that it just blacks out the whole plot. So I'm just going to comment this out. And what we're going to do now is we're going to run this operation where we're saying, look, take the square of every x value and the square of every y value and add each of them together respectively. Now remember, this is just the y, but it's taking the -5 from here and the -5 from x, and it's squaring -5 to get a 25, and then it's squaring the other -5 to get another 25, and it's adding them together. So that's why we get 50 at this value point. Just as vectorized operations can replace these for loops to enact equations like this, we also have an alternative for the if-else condition in NumPy. The np.where method is like the ternary expressions that we explored in our Python data science course. A normal Python if function says, if there's a condition, do x or else do y. But what a ternary expression does is it displaces the do this portion of that. We actually move it out of place and put it at the beginning. So the condition comes second. The primary execution proceeds, and the secondary execution comes after. The np.where method performs similarly to that. As we've seen with other complex operations in Python, it's much easier to perform such an operation with the NumPy method. Here's a Python solution for this operation compared to a NumPy solution for this operation. So let's discuss what's going on. We have 3 arrays here, an X array, a Y array, and a condition. All 3 of these are one-dimensional arrays with 1, 2, 3, 4, 5 values. And then we're going to zip these all together. So we're saying take the matching index from all of these and relate them together. And then we're going to unpack them into an X and a Y and a C variables. So that's what the loop portion is doing here. And then we're going to check that with the ternary statement and say, look, if the condition is true, output the X value, but if the condition is false, output the Y value. So let's run that and see what we get again. And where this is true, we're getting the X value right here, but where it's false, we're getting the Y value right here. But in both of these cases, it's true, so we're going to get X in these cases. And where this is false, once again, we're going to get the Y value. So just to explore what happened above, let's look at what this zip function does. It relates the 0 index of all 3 of these together. It relates the 1 index of all 3 of these together, and so on. Right? So you can see that happening here. So that's what that zip function does. Well, we can replace all of this simply with this where function. So if we run that down here, we'll get the same results with the NP-where version as we did with the Python version. And yet, look how simple this is in comparison.